Okay, here's a question submitted from one of our classmates, and it's a sum. Okay, it's a finite sum, and I want to use the formula that I like to use, and we all should know it well. That if we have a sum of an arithmetic sequence, we can use the formula Sn is equal to n over 2, the first term plus the last term. So notice that I said that we can only use this formula if we have an arithmetic series. So, an arithmetic sequence. So let's just make sure we have that. Okay, so this up here is we're summing an arithmetic sequence. Okay, I hope I said that right. So here's our sequence. Okay, and it goes all the way up to 2044, and we say in an arithmetic sequence, if the difference between all the terms is constant, and we know that this is 6, this is 6, and we can check, and that's enough for us here. You could also see that the difference between these two terms is also 6. So yes, this is a arithmetic sequence. Okay, very good. So we're allowed to use this formula. So let's go ahead and see if we can use it. So Sn, oh wait a minute, I don't know how many n's there are. How am I going to figure that out? Well, let's put in some numbers. So here's our negative 50, that's our first term, and here is our second term. And the big question is, how do I find that n? So let's look at a simpler example here and see if we can figure out how to find that n. For example, let's just look at something really simple. 2, 4, 6, 8, 10, 12, 14. Okay, let's stop there. And let's notice the amount of terms that are between here. 1, 2, 3, 4, 5, 6, 7. And I hope you agree that this is a arithmetic sequence, because the difference between, and these spots are gonna be important here soon, are each 2. Okay, so I didn't have to write all that out, but I did. Okay, so and then let's pretend one more step, okay, that we didn't know, okay, all those terms between here. And obviously in this case we can count that, so that's not a hard one to find, so let's just count it. But if I show you how to do it with this, you'll know how to do it with something that's not so easy to count. Okay, so the first thing that we want to notice is how much did we increase by from the first term to the last term. So what do I mean by that? I mean there was an increase from 2 all the way to 14. So that means we increased by 12 times. Okay, we increased 12 times by 2. So if I divide by 2, I'll get the amount of times that I increased by 2. Okay, so 12 divided by 2 is 6. And what I'm saying here is, I'm saying how many times, okay, did we increase this sequence by 2? And I'm counting all the spaces in between these numbers. I'm counting how many spaces there are. So I really hope you notice, okay, that it's counting one less than the number of terms in the sequence. So if I had one more, okay, one more increase, okay, there'd be one more space, and therefore we would get another term. So here, since I know how many times I increased by 2, okay, if I know how many times I increased by 2, I will know how many spaces there are. And that's where we have to remember to include the first term, because we're only counting spaces, we're not counting terms. So that means I have to take the amount of increases that I did, and I have to add 1. And there you see how I got 7. So 7 here using this technique where I find out how much we increased from the first spot to the last spot, okay, and if I divide that by the size of the spaces between each step, okay, I'll find how many spaces there are. And how many spaces will dictate how many terms there are. There'll be one more term. Okay, I hope that works. So let's go ahead and see what we have here. Okay, so our increase, let's see, our first guy was, we went from negative 50 all the way up to 2044. So be careful with your negatives. Okay, so I essentially, not essentially, I did increase by 50. So that means I increased from my first term of negative 50 all the way up to 2044, and that would be what? 2090. Okay, but what was the difference between each step? So up here I said it was 6. Okay, so let's see. All I have to do now is take this number, and divide by 6. And I think I have that number somewhere. Hold on one second. I'm going to take 2090 and divide by 6. I forgot a 4, didn't I, folks? Sorry for the pause. I should learn to add, I guess. All this, I'm not making a new video. All right, so 2094 divided by 6. Okay, let me get you that number. And we get 349. Okay, so we counted the amount of spaces now. Okay, so that means we have to take our 349 and add 1 to get 350 terms. So that means n is equal to 350. Okay, that was a bit. So you use the use con assignments and practice these as much as you can. Okay, and let's go ahead and finish this problem. So let's see. N is 350 divided by 2 times the first term plus the last term. I think it was 2044, is that right? What was it? Yeah, 2044. Okay, so we do some math. We take 350 and we add negative 50 and 2044. We'll get 997 times 350, and that comes out to be 348,950. So S of 350, our N, is equal to 348,950. All right. Other than the addition, that's what happens when you go fast and you're talking fast. So this was definitely the crux of the lesson here, is really determining how you find n. And remember, if we know how many spaces, if we add 1, we'll find out how many terms. Okay, I hope this helps.